Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
We'll start. Thank you very much for coming. It is with great pleasure that I get to host Henning here. Henning is a professor of computer science at Columbia University. He's also the department chair. He received his PhD from University of Massachusetts, and he's done a whole bunch of things. I was trying to figure out what exactly I should say, but the fact that all of you are here tells me that you obviously know about him. And so I'll just point out a few things. He was a technical staff member at AT&T Bell Labs. Come on in. Starting. And he was also the associate department head at GMD Focus. He is very, very active in the research community, both as a contributor in writing papers that have had tremendous impact, and also as a leader in the community. I'm sure all of you who have published papers do know about the EDAS system, and he's to blame for that. And also beyond that, he's on the editorial board of many, many journals, including the IEEE Transactions on Networking, and he's the former editor of the Internet Computing Magazine. He's also a member of the IAB. And he serves as a chief scientist for SIPQuest and a chief scientific advisor for Ubiquity Software. So Henning's going to talk about Beyond VoIP, and all yours.
Thank you. I do appreciate everybody coming. I recognize a few faces, but I obviously don't know most of you. So I don't know what the standard operating procedure is around here. I'm happy to take questions in between. I don't know if the facilities make that advisable. But what I want to do today is kind of a bit of a romp through what I see as kind of voice over IP 2.0. In the sense of these are primarily things that we've worked on in my lab. Many others do in some instances as well. So this is in no way trying to diminish the contributions of others that are working in those areas, and really illustrate where I see that where we used to focus in the networking community as well as in kind of more of a standardization and industrial community on voice over IP core functionality, essentially feature equivalency to the 125-year-old phone system. And we are now finally, I've been trying to say that for a while, but I think we're finally there that we can move on beyond that. So I'll talk a little bit about kind of a big picture, what I see as the transitions happening in voice over IP, and something which I'm not sure that's a theory I can prove. It is more of a gut feel that I believe that actually what's happening is that the emphasis now is shifting from media as the focus and how do I do voice codecs, video codecs, all of that, which was a lot of work being done, obviously, in the mid-90s up to fairly recently, kind of the whole MPEG and H.264 and the AMR voice codecs and all of that, variable rate codecs. A lot of exploration into that. That seems to have subsided somewhat. And we're now transitioning where I believe we're not so much media is at the core, but the metadata. Really dealing with voice streams, media streams, video streams as really entities you can work with and sessions you can work with rather than just as plain old media. So there's several aspects to that which go kind of in that metadata theme. One is that you provide more signaling information, part of presence, for example, which I'll talk a little bit about, some of the extensions to that. Notions such as caller preferences, which give more control to users as to what happens to their voice calls and their multimedia calls in general. The notion of events as a unifying principle in multimedia services as something which you use as part of multimedia services to structure those, as well as a new building block, which we haven't really had in that form. One aspect of that, which we have not seen, is in a sense you can think of voice over IP at roughly the stage where the web was, I don't know, in the late 90s, where there was a lot of emphasis on building personal home pages, editing HTML, and people having kind of their web presence there, and maybe even you had GeoCities and things like that, pre-canned systems. Largely what we have today for voice over IP systems are canned systems. You get what the vendor believes you should have, and that's it. There have been attempts, not very successful, to kind of expose APIs, but I believe now we're ready to move to a more programmable model of multimedia services. And note, I'm not using the word middleware, and I hope it's the last time I use that during this talk. So no, I'm not talking about middleware here. And then we've had to now deal with some of the less pleasant aspects of becoming somewhat popular. It's not a big problem yet, but we will sooner or later have people making unsolicited phone calls, using and sending instant messages and all the other things, using IP technology, which in many ways is ideally suited for automation, which obviously is ideally suited for spamming people. And so we need to start thinking about that. So I want to just highlight one or two things that we're investigating in that. An area where that I mean, if you'd asked me a few years ago as to research topics to get involved with, I never would have thought to list emergency services among those. But what I've started to realize, at least, and I'm sure, I mean, it must be one of the kind of latecomers to that realization, is that in the networking world, I tended to think of systems and protocols primarily kind of as boxes. You connect them, you have a web server, you have a web client, and that's it. Or you have a phone and an epoxy server, that's it. We are now at least coming to a realization that the phone system, which we are now starting to replace, is actually much larger than that. There is large-scale infrastructure associated with that, expectation, user expectations, social expectations, and indeed that much more than any technology that most of us get to touch, it becomes a life and death matter. Suddenly people depend on this stuff not to play video games, not to send email, but to get plucked off roofs when there's a hurricane. And if it doesn't work, which is exactly what happened most recently, suddenly there's a lot of interest in looking at why that isn't happening. And I'll talk a little bit about some of our efforts in that particular area to move beyond really 20-year-old technology in that field. And time permitting, I'll talk about a topic that's really just very early work in my research group on looking at how do you maintain reliable systems that are really very large and complex systems where management in the traditional way, namely centralized management, kind of the open view style of management, is no longer sustainable. You can view what's happening as a philosophy transition. We started out with essentially the one computer or one phone for many, many different users. Kind of the mainframe, the home phone era. So you would all share one phone, and until a few years ago you weren't even allowed to plug in a second one. The party line thing. Obviously we've moved way beyond that. But we've largely now in the one computer or one phone per person model outside kind of a technical community on that. Kind of a cell phone era and the PC era type thing, or a mobile computing era. You have your primary device that you have. I believe we're starting to transition a bit, even though obviously the other things continue to exist, into an environment where you have a much larger number of devices that serve a user over time, in the sense that you're no longer associated with a device that you carry, that a device, including phone-like devices, that are embedded into the environment, embedded into things that you don't really think of as phones, and I have one or two examples of that as I go along. That is really kind of a strange intersection where some of the voice over IP community and the ubiquitous computing community are starting to intersect, although they don't realize that in many cases. They seem to be relatively separate worlds right now, where the ubiquitous computing community seems to have particular emphasis on fairly small scale systems, localized systems, sometimes middleware-based systems in many cases, while the voice over IP community tends to think of as large-scale systems, but pretty dumb systems, generally speaking. And we're now only seeing that really many of the problems that the ubiquitous computing communities were trying to solve and the ones that the voice over IP traditional telecommunications community are trying to solve are starting to converge, and the problems are fairly similar. So I've been kind of a little bit nibbling, so to say, on both sides of the buffet, and it's kind of interesting to see that how little awareness is, even though the problems are fairly similar. The other kind of big-scale transition that's taking place, that the emphasis, if you kind of go by the keynote themes, when I went to Infocom conferences a few years ago, you could predict the theme of a keynote. There would be a variation on the theme that we are well on our way, and these are some of the obstacles we have to overcome to have media anywhere, kind of a whole mobility thing, anytime, continuous connectivity, any media, multimedia type thing. Well, we've done that. What they didn't tell us that most users these days want not quite that. We got that in spades is in most, let's say developed places, obviously that's not universal, is that they want it in the right place in the right device. They want it at the right time, and they want the right media. Namely, they don't want the cell phone to ring, which will invariably happen sometime during this talk, when somebody is speaking. They don't want to necessarily have a video call when they're in a public place, and other things. So the emphasis is now no longer get the bits there, but get the right bits to the right place. And we have not done as well on that score. Right? It's kind of not an indication that that we've been successful as a research community. If you ask a kind of normal people, so to say, not researchers, probably what the two largest problems are for communications today, I suspect they'll tell you two things: spam and these darn cell phones that that ring in a restaurant, in a train, or whatever else. Both of these problems are problems, abundance of communication, the wrong communication at the wrong time. We've not really tackled that problem very well. Also, if you look at collaboration system, which is kind of a third bubble that seems to exist largely independent of the telecommunication and the ubiquitous computing bubble, is we've had a lot of emphasis on intra-company, inter-organization collaboration. We're now slowly moving to a more open environment, but we still don't have many of the pieces necessary. I'll have a few items to talk, a few issues to talk about that a little bit later. If you look at kind of from a historical perspective, I would roughly divide, and I guess that would make it version 3.0 I'm talking about here, the voice over IP evolution into three components. Namely, the first one was the mid-90s when the first commercial systems came about. Voice over IP obviously dates back. If you take the first beginnings of an attempt to transmit voice over the internet, it was within 2 or 3 years of the beginning of the internet in the early 70s. But kind of the next real attempt in the mid-90s, the amazing thing was that it worked at all. The phone rang, you could talk across this internet thing, and it just kind of worked. Well, that barely, in many cases, long delays, all of that. But that was kind of interesting for a few years. And then people said, well, I got this phone. Once this moved out of a research community, I got into a company that says, you may not have that, but I got a phone here made by Nortel or Lucent or whatever, which has all these nifty features. Can your newfangled IP phone do call transfer? Call transfer? What's that? Can it do follow me? Can it do park calls? All these myriad of features that had accumulated outside the normal computer world, so to say. And so lots of people spend a lot of time, and that's to some extent ongoing, to just reach feature parity, that all these things that make things complex in the real world, because you need to do call transfer, because you have all these other services that people expect beyond just simply dialing a number. And even the dialing a number part turns out to be more complex once you get into all the kind of nitty-gritty of it. So about 3 years, 4 years or so, we spent essentially doing that. And I'd say, but starting maybe a year or two ago, people said, okay, we got most of that done, maybe not products, but at least we know how to do this. And now the challenge is we got this stuff, and the phone still hasn't stopped ringing. It still rings when I'm in a meeting. It still doesn't do the right thing, and how can we fix that? So people hopefully are now raising their expectations a bit and going beyond just the black phone equivalence, which is largely what we've accomplished so far. Also, from a protocol perspective, and I'm not going to talk a whole lot here about protocols in great detail. I'd be happy to do that one-on-one or any questions that you might have, is that we've essentially, but we didn't realize that, filled in some of the protocol gaps that we had. And one way to look at that is in these a layering model, kind of the good old 7-layer model that we've had, is that we really haven't had a session layer, for example, and a presentation layer, and we've started to fill in those things. Another way of looking at that is that we really had kind of a quadrant of functionality that we want in networking at the application layer. Namely, we want push delivery and pull delivery. We want synchronous and asynchronous. Now, it's obviously more of a line than a division, but bear with me for that. And so you have a push delivery, and so we have for asynchronous messaging, email variations on that, or web services messaging, things of that nature, where you don't expect instantaneous delivery, unbounded delivery time. Then you have synchronous delivery for push. We've had relatively little of that. Certainly little of that was terribly successful. So media on demand wasn't terribly successful. But then most recently, things which have been successful all kind of fall into that area, namely instant messaging, presence, event notification, and session setup all have this notion of tight time constraints to be useful, and it's a push in a sense that the other side initiates the communication as opposed to the recipient of that information. Pull information we've obviously had for a long, long time, the whole web, FTP, and all of these other things. Remote procedure calls, all pretty much the same once you kind of strip away the peculiarities of implementation. And obviously, one piece that is largely missing is pull and asynchronous, the ability to asynchronously deliver large content on demand. To some extent, the peer-to-peer file sharing systems like BitTorrent fulfill that rough notion. In a sense, you don't expect instantaneous delivery, but it is a pull-based mechanism largely. If you map that to protocols, you then find that in essentially have reasonable answers to all quadrants, except possibly the last one in the lower right-hand corner, namely asynchronous pull mechanisms. We don't really have a standardized mechanism for that. We have obviously lots of reasonably implemented versions of peer-to-peer style pull mechanisms there, and other things, delay-tolerant network type things that go into that. But in the push arena, we've now had both at the data level and the control level have the protocols to actually make that happen. That's pretty recent. One of the things I wanted to emphasize, and again, I'm not going to talk much here about protocols, is just to drive home a point, is we tend to focus on kind of protocols because that's what we do in networking. I mean, the web is HTTP, or email is SMTP. And that's somewhat useful, but not particularly useful in this particular arena, I think. And this is just an illustration of the fact that what we really have here in this notion of voice over IP synchronous multimedia communication, that we have a set of things that all need to play together. They're independently developed largely. They're relatively modular components in the sense that they don't need to know a whole lot about each other, but they need to work together in order to really make anything happen. Otherwise, just by having, say, RTSP or SIP or RTP or stun return or any of these other things, or XCON or whatever, you're not going to get a real usable system. That's also different. We are not used to that in the networking standardization community, certainly. If some of you are involved in the IETF, there's right now a lot of discussion on creating a new area, standardization area in the IETF just for real-time communication. They can't even agree on a name. Everybody kind of knows what falls into that. It's roughly what's on the slide. But how do you delineate it? It kind of feels like it belongs together, but we don't have an architecture for it. We kind of just keep adding pieces to it on various points because we need functionality. Not necessarily the best way to do it, but that seems to be the way it evolves. The other problem that we have to deal with is that we are dealing, because of a transition, we have a cultural problem. There's the old nethead versus bellhead issue, and we see that at the protocol layer. I mean, I've been involved in this now for a number of years, and you kind of end up playing in both areas. You have to support the old stuff, so you deal with things like overlap dialing is what you need to do on a rotary dial phone, because digits come in one after the other, and there's no return key on a rotary dial phone, so, or send key, so you need to deal with that. That doesn't quite work well with what we assume how protocol should work. We need to carry touch tones, because otherwise you can't talk to your bank or whatever. You need to deal with things like key systems, all notion of lines, like phone lines as virtual lines. All these familiar concepts, people expect those to work in the new environment. That has consumed an inordinate amount of time and effort to kind of make that mostly work. Then on the other side, we have things we want to do. Multimedia, we want to do instant messaging presence, location-based services, user-created services, which I'll talk about later. We want to have a more decentralized operations, maybe even peer-to-peer in that environment. We have a trust model, which is very different, namely that everyone is equally a suspect, as opposed to the good phone company and the bad customer model, which pervaded earlier. All of these things are fundamentally diametrically opposed assumptions, which make it interesting that a protocol space becomes a battlefield, so to say, for very different philosophies, namely philosophy, kind of internet-style philosophy, old-style internet philosophy, decentralization, versus a centralized more philosophy, which is often more economically successful. So protocols are more than just simple bit carriage. They're actually, in some sense, and this goes back to some of the papers some of you might have heard about, the Tussle paper, really become battlefields where you decide as to how the world shapes up. I won't talk about this here. I just want to kind of, this is really an illustration only to say that what we think of as a simple phone system type of thing, just dial, it's just, how is voice over IP fundamentally different from email? You have an address, you send a message there, and you send data. Basically the same. What you don't have and not expect in that general world of email services is all the stuff that you expect to do in terms of control. And that adds to this relatively complex overall system that you have to then deal with. And I decided no point going through that. So one of the things that we had to deal with was, in terms of protocol design, was to design a system which had was able to play in both system worlds, because otherwise it would never have been successful as a protocol if we hadn't played in both the old world and the new world. You can't just, if you want to essentially compete with a well-entrenched competitor, which was at the time H323 had essentially nailed up the multimedia field when we started. And so we needed to provide feature parity and do things slightly differently as well. So we want to provide new features, and particularly ones which are not available in the PSDN. But we don't want to do replacement. So for example, H323 had chosen to make a design assumption that they basically did ISDN signaling over IP. That was a fundamental design assumption, which had some advantages, but it led to a fairly awkward design in many ways. And we wanted to get away from the old model of having essentially a signaling message for each new service, because that's really the old phone model, that you have very service-specific things. Here, we attempt to generalize concepts about things which are similar, strategically become similar from a networking perspective. Clients are heterogeneous. They can be smart and they can be dumb. You don't just have dumb terminals like you have in the traditional phone system, but you don't have only PCs like you have in the classical data world either. Can't just assume that. And that was really even before mobile terminals became a realistic option. We worked on the first voice over IP embedded system. All it had was a single digital signal processing chip. So we had to do all the protocol implementation on a Texas Instruments DSP. It doesn't give you a whole lot of room to play with. It has to be hardware, software compatible. Clearly can't just run on software-only devices which have a full-blown operating system. It has to support client multiplicity, in the sense that you have a single user with multiple clients. We don't support that very well if you look at other internet protocols. For example, email, if you want to share mailboxes, that doesn't tend to work very well. There's no real good locking mechanisms, for example, if you look at IMAP and things like that. We needed to explicitly address that because systems that we had to replace exactly expect that. And clearly want to support multimedia from the beginning. As I mentioned, there's really now a battle going on between kind of the old world and the new, but there's also now a newer one, what's known as NGN, a next generation network. I'm not sure how many of you have been involved in that type of discussion. I suspect it's more something you do if you're in a telecom company. But there are now people talking about essentially re-engineering the existing landline phone system as a voice over IP system, but in a slightly different way than you would necessarily expect if you come from an internet environment. Namely, the old notion that services that you interconnect at the IP layer, that you have the exchange packets and applications reside somewhat mysteriously in clouds above. That's not the NGN model. The NGN model is that you have a per-service interconnection. So you interconnect, you do peering at voice over IP, you do peering for multimedia streaming, you do peering for email, etc. You do peering for web. Every service has its own peering arrangement. You have devices which are end system controlled. We had a discussion earlier on the difficulty of doing development in mobile devices because carriers control that. The end systems, they don't allow anybody to just put things on there. That's now true in gaming devices. It's true in mobile devices. And if the phone companies have their way, it will also be true in end systems attached to to voice service supporting devices. State preference. You can kind of divide the world into the stateful and the stateless people. That prefer from a design approach. And clearly, even though circuit switching has kind of fallen out of favor, the mentality, and that's not there's justifications for that, mentality of stateful circuit-like approaches where devices in the network maintain state is very much still there. So that's a debate which continues to go on. So even if you thought that the circuit versus packet debate had subsided after the ATM discussions, we have a new version of that coming up. Doesn't seem to go away. Interconnecting versus prearranged versus kind of ad hoc. We are used to an ad hoc arrangement. You don't have to negotiate with an email provider, send email to that person. You just look up the IP, the domain name, the MX record, send a packet to port 25, and that's that. That's not the model here. It's a prearranged peering arrangement, very much similar to what you would find for cell phone carriers, say, that do that. You have a billing model differences, packets versus services. That's a real economic issue where you can have a long discussion on that, where you could probably prove that the per-service model is, from a carrier perspective, much preferable because users value different bits differently. And the internet doesn't allow you to express that very well. And so because voice bits are valued much more highly than data bits, generally speaking. And that's, in a sense, the success of mobile phone carriers resides on that. And clearinghouses, et cetera, versus sender keep. We'll now talk about some of the meta information that we discussed early on. So the classical model of a phone system, you can kind of summarize that as guess, ring, and annoy. You guess whether the person is available. You ring the phone to see if that person, if somebody answers, and in more cases than not, you annoy the person by doing so, because that person is really doing something else. And we've done that model for roughly 125 years. Nobody likes it, but it doesn't seem to have been fixed in any real way. So we have a high probability of failure, good old telephone tag. We have big calls during meetings. We have the inappropriate media type of problems, which is becoming more of an issue, mobile clients even. The current solution that we've tried haven't worked. We've tried to convert voice into an asynchronous media by voicemail, but nobody that I know of likes voicemail, and I try to ignore it as much as possible, simply because it's tedious to deal with. It's hard to, you can't structure it very well. You can't file it very well. It just doesn't work very well. So most people, given a choice, will not use it. And we have things like automated callbacks on busy and all of them. When somebody's no longer busy, nobody's ever used that. It just doesn't work well enough. So from what I can see is we have now two types of actual phone calls going on. Namely ones which are spontaneous, and they're mostly of the guess, ring, and annoy variety. And they usually work in the private sphere reasonably well, in business sphere not so much. Most of the phone calls that I do that exceed a minute or two are now scheduled by email ahead of time. You sort of signaling by email, and then you actually set up a call, so to say, at the predetermined time. Not terribly efficient mechanism, but we should be able to do better. So I'm hoping that we can actually essentially get rid of the model that you just simply blindly call somebody out of the blue and just assume that the person wants to talk to you. That's no longer a viable assumption. We need to facilitate unscheduled communication. We're still going to have these hour-long conversations, and you're going to do something hopefully a little better than what we do today beyond just single domain Outlook scheduling. But we need, for the unscheduled one, we hopefully can do better than that. By providing recipient-specific information that tells me as to what state the other person is in before I actually just kind of probe by sending an invite request to them. And to allow me to distinguish between asynchronous and synchronous communication as the most appropriate means of communicating with that person. Choose media. Right now, I have no good way to tell whether the other person, for example, would prefer text, because they're sitting in a meeting. They can text just fine. They just don't want to talk. And I want to predict the availability of a person in the near future. Currently, what I have is the problem. I try to call somebody, and the person then tells me, I'd like to talk to you, but I'm already late for the meeting, or I'm already late to go to the airport, and both of you just wasted time. So we don't just care about spontaneous availability right now. I mean, I'm available at that very moment, but not for a sufficient amount of time to complete the communication or discussion. So one prediction that we need to, I believe, we're moving towards, that we're now bifurcating communication into two modes, namely pre-scheduled, kind of long-range, multi-party communication, ranged through some synchronization mechanism, a scheduling mechanism, or a presence-initiated one. Kind of the notion of a classical phone model will become the exception, at least in professional communication. That leads to the notion of having more context in communication. Generally today, we have essentially zero. We know the number of that person. We don't even know whether that's a phone number or a fax number if we're not careful. We need to know more about what that person is doing, what's going on the other side, meta information about the state of the other side. And that's more than, well, it can be something simple as what time of day is it at the other side, so I don't call it middle of the night. What capabilities does the other side have and want to expose? What is the location that the other side is at? That might be the geographic location, or that might tell me something about the location, not just where you are. That's not necessarily interesting. For example, right now, it's not terribly interesting that I'm at a specific geo-coordinate. The interesting fact is that I'm in a meeting room, and that has certain properties. The activity and availability. What can I do? What am I doing right now? Meaning how interruptible am I, and how available am I? So that's the whole presence notion. And longer term, you could even imagine that you incorporate more sensor data into that. For example, you might have some measurement of the mood that you're in, so that maybe that if it's not a good time to call your boss to talk about a salary raise, if that person today happens to be in a particularly surly mood or not, or just rushed or whatever. And I've had this happen on a number of occasions where somebody probably didn't get the phone treatment that they deserved simply because I wasn't feeling up to it. That raises, along with the other ones, privacy issues, which we need to deal with. I'll talk about those in a little bit as well. So currently what we have, you could call that basic presence. Namely, the idea was presence you had, can I send an instant message to that person on AOL because they have a modem? And clearly if they're not logged in, that's not going to be too helpful. Same notion as is the cell phone on type of deal. That's no longer interesting in any technical sense. Now the question really is, what media do I need to use? Is it disruptive or not? or is the caller even awake, as opposed to the PC plugged in. And all of the existing systems that I'm aware of are commercially available systems, MSN, Yahoo, Google, Skype, all of those present services have essentially only the red-green distinction, online, offline, with few variations on that, plus a simple status information. I mean, I don't know about you if you use, who uses presence, but instant messaging kind of clients, when I use it, but I never change. I'm always green on this thing. According to that, I live a rather idyllic existence of always being available 24/7 on my computer for anybody to talk to me, simply because I don't have time to do that. So my basic rule is if a user had time to actually update it, they probably have too much time on their hand. They don't really need presence information anyway. So we clearly need to do better than that. And plus the availability, non-availability doesn't provide enough information to that. It's generally global. I'm much more interruptible to, say, my assistant and the dean than I am to my students or maybe a colleague, for example. So we have now developed within the simple working group a data model for somewhat richer presence than the simple notion of on-off type of model that we have today in commercial systems. Particularly, we recognize that we're going to have data sources beyond just the manual configuration that all the event clients, presence clients have today. For example, your calendar is likely going to be an event source. Your cell phone, not manually entered, but simply because you've used it or it's in range or out of range, and as well as manual one. You're going to have services, and not just one, but voice services as well as text services, video services, which are mapped to multiple devices. Currently, we essentially assume that you're on one device. If you look at all the commercial clients, in many cases, I know this is the problem Yahoo client has, is when you log into one device, you actually get logged, logically speaking, logged out the other device, even though you might actually be using them both at the same time. They can't reflect the richness of communication relationships that we actually have today in terms of price. However, because the presence data can get fairly complex in the sense of multiple sources, time varying, all of that, we have now specified a data flow model for dealing with that metadata. A composition policy where you take possibly contradictory data published by a variety of devices, from traditional phones to mobile devices to calendars to anything else you might have, sensors of various sort, room sensors, for example. Compose that into something which makes sense, is non-contradictory to the extent that you can make that happen. So, for example, you might want to, if multiple sources report your location, you might say the device that actually is moving is more likely to be correct because the other one is probably sitting in my desk drawer somewhere. I just left it there, and if that location is reported, it's probably not particularly useful. Then I need to do privacy filtering. One of the big problems invariably comes up during discussions of this is, you mean you actually want to tell everybody about all of these things that I just mentioned? No, you don't. You want to tell some people sometime about some of these things. So we need to have a mechanism of having a privacy policy which we don't have with existing systems. If you look at existing systems, you can basically put somebody on your list and they get everything, or you can put somebody not on your list and they get nothing. But that's not what you want. You want somebody to know, even if you don't care much about sharing your private life with them, that you're not reachable right now, but you don't want to tell them exactly where you are. Your spouse maybe has it simplifies life if they know where you are because they can predict as to when you're going to be home, etc. That's something we can't do. We need to be able to do that in a portable and easy-to-use manner. Watchers have different requirements as to what information they want. Some want very basic information. Some want all the details. And then there's issues of merging things when there is no longer an event because you've filtered out all the relevant information. That notion now is converging into something called rich presence, which is presence with the assumption that it's derived automatically from sensors of various sort. So physical sensors, movement sensors of various sorts. So for example, in our lab, we have built various sensors which use Bluetooth to detect the presence of cell phones, as well as swipe cards, just presence infrared sensors, etc. and as well as electronic activity calendaring, typically, but could be as well as email, could be other services as well that detect where you are, what you're doing. That is raw data that you don't want to expose directly to other users. You want to filter, combine, reduce that information. Multiple contacts, both current and planned activity, your surroundings. How noisy is it? Does it make sense to have a voice call? Are you driving, for example? Do you really want to have that voice call? Are you in a private place where you have a conversation that is private, or is it a place where that's probably not a good idea? As well as, are you composing information right now when you're responding? This is just the type of elements that are in there, not just as an illustration here as to what all you can do and indicate in that data format. One of the interesting things is that presence information makes sense as system glue. I see actually event notification and presence as a mechanism to tie together loosely systems that need to talk to each other but don't trust each other a whole lot. We've tried to do that in various ways with various middleware Genie-style approaches. It doesn't seem to have worked very well because it assumed a relatively strict trust model that the trust was universal and uniform. That's generally not the case. We want is a narrow interface that exposes information about people, events, and activities for people, for example, and then uses that information to derive other things from that without having tight coupling, say, between my cell phone company's internals and my call routing logic. So for example, here in the system that we are building, you have a presence agent where presence information is published. Different devices are notified, and that translate this into a logic. CPL is one of the logic languages I'll talk about in a little bit, or one variation of it, which namely LESS, which is an end system service creation language, which then determines how calls are routed, for example. So that's my calendar doesn't have to know about what my policies are when I'm reachable or not. That's not a province of a calendar. It simply exposes presence information. I have a single point of call logic that I implement that uses that external information and then does call routing without either of those end systems having to be involved either. They don't have to get access to my presence information either. So you can do simple services, for example, with that. So, for example, if the activities here exposed through the presence agent indicate that you're in a meeting, then route the call to my assistant. Or if I have multiple contacts, try the one where I've been active most recently, based on indications of media use, for example. How do you deal with privacy? So in the IETF, we're specifying a privacy language, which allows you to specify who can get what information when. That's actually a somewhat interesting problem simply because there's been plenty of rule-based logic for privacy services and access control and things like ACL type things. None of those work. One of the challenges, for example, is that these have to be composable where multiple policy agents can combine to provide a single policy. ACLs don't compose very well, typically. Ordering matters, for example, for most ACLs. First rule wins type of thing. Here we've designed a system which essentially is a set theoretic model of providing access control in a way which is predictable and safe. Safe meaning that when you remove rules, because a system that is remote, for example, has failed or is not reachable, you want to fail safe. Namely, you want to never expose more information than you already, minimal that you're willing to expose. If you have ACLs with broad permissions, you can get yourself into situations, if you're not careful, where the removal of a policy agent gives somebody more permissions than they had previously, or the wrong permission. One of the presence items that we need to deal with is location. That's actually kind of one of the most rich pieces of information that you can have. You can do things with it which are hard to do anywhere else. People have talked a lot in the ubiquitous system community about location-based services. When you see a lot, it's kind of one of those things where kind of next challenges, invariably somewhere people talk about applications, it's applications based on services, on locations. In the communication realm, I think we have some relatively interesting opportunities there, which are not the same old find nearest ATM, restaurant, whatever type of variety, but actually change incoming communication based on where I am automatically, so that if I am in a room which is designated as a quiet room, maybe that communication will be redirected or reconfigured in terms of media. Have the devices in the room adapt themselves automatically to their users. So we've built a system, which I'm not going to talk about here, where when you walk into a room, the devices temporarily become yours. They're personalized to your use based on the same presence mechanisms. Awareness of my location, who is in my neighborhood, as well as security, so that proximity grants you temporary rights, for example, to project something on the screen, which I implicitly now do simply because I'm in the same room and I can plug into the jack. So we've been experimenting with some location-based call routing services with NSEP. So for example, the inbound call routing for forwarding, outbound call routing for kind of pizza delivery style things for Pizza Hut model, as well as location-based events, namely subscribe to locations, not people. Care about a particular, what happens in a room, not what happens to a person, but it can be modeled in the same protocol fashion. Created a service creation tool which allows you to then create those type of services in a language I'll talk about without actually writing code in that. So the idea is that users can very quickly drag and drop these type of services, change them, save them, and activate those as they make sense. Talk a bit more now about service creation. So in particular, we've spent a lot of time in the voice over IP community on just the signaling aspect. How do I get calls from A to B? How do I get services? Less effort on making sure that we can actually program those services in a distributed fashion. The old model, the vendor programs. Now I believe the model needs to be that the user or some proxy for that user, sysadmin, vertical provider, vertical application provider, can do that. To see basically four different niches of programming. Namely, one where you program in network servers, and that's done by programmers. That's the traditional version of that. Others, however, you want end users to be able to program services without interfering with other services and other users. It has to be safe for a service provider to do that. So to say, the genius of HTML was that you could get a hosting provider to offer you a service, and they could be pretty sure as long as you only put HTML on there on your web page, it wouldn't interfere with anybody else, and you could share the same infrastructure. We need the same model for voice over IP. At the end system layer, we have, again, program-oriented type of functionality. So voice XML is something which is primarily for voice, text-to-speech, speech-to-text type of services, and IVR-style services. And scripting and RPC services, where you simply script an end system to do certain things, kind of a DCOM-COM model to some extent. But also have programmability at the end system end user level, not trained programmers, where somebody who can program HTML or equivalent or can generate that automatically through a wizard-style mechanism can indeed generate end system services which may not have existed before. Oops, this slide got somewhere in the wrong order, so I'll skip it in interest of privacy. Okay, so the programming that we have is we've had programming of services through CTI, computer telephony integration. I'm not sure if anybody's heard of that, but it was a big thing in the voice field, I don't know, 15 years ago, something like that, mid-80s, early 80s, 20 years ago almost now. In call centers where the screen pop, that was kind of the epitome of that service. Caller comes in, you look at the caller ID, and you do the database dip, and the terminal would show the customer record. That was kind of what you wanted to do with that. Not terribly interesting. It was rarely used outside of a narrow confine. We now have the model of calling external programs. Skype actually did this very well. They have a closed source system, closed protocol system. So making it difficult to extend for new services, but they have a programming interface into their software. So you can actually send messages to that software to do certain things like dial, pick up, and so on. That allows you already to do a lot of new things that weren't originally, should say, anticipated in that. And you can do scripting APIs. That's starting to happen so that you embed scripting languages into clients. It's not very popular right now. I don't know why, but that seems like a very easy way to generate services. Put PHP or Python or whatever your favorite scripting language is into that. So we have to build a model for that for servers called SIP-CGI, which is essentially the CGI model, the web programming CGI model. You can run that on Perl script, say, on a SIP proxy server. It has turned out to be quite useful for doing quick service development. You can make it controllable, certainly through web service interfaces. And you might make it embeddable in the sense that you don't just have, right now, all the applications, generally speaking, tend to be in your face. It's a phone application. They even often look like a phone, I mean, an old phone usually. In many cases, and I'll cite an example in a minute, you want more than that. So what are kind of the end system services you want? Is you want not just the phone to be part of its own system, but you want to integrate that with the rest of the world. So this is the first one is a service that we've done. So if a call comes in from a certain person, you not just answer, but you also turn off the stereo at the same time, just by controlling it through a control interface. As soon as somebody's online, call that person. Now you can build all of these services one by one as pre-programmed services. You're never going to get done. You want a service logic where you can build both quickly and in a personalized fashion without being a programmer. So we've developed a language locally, called LESS, Language for End System Services, which is designed to be a very simple language. It can't do computation. It can't do a lot of things that a real language would have to do. I mean, no threading, no memory allocation, none of these things that you would need to do in a C or Java-like language. It is really just a domain-specific language which is designed as an event model-based language. You have triggers coming in, events outside, be it notifications or calls, actions and switches that modify behavior based on that. So the idea is to have something which is easy to understand conceptually. Users just realize I have to have an event trigger. I mean, they don't call it event trigger. I have to have something which happens when there is an incoming call. Just drag some icons for that. And I want to make it to be able to analyze the service. So then we have it essentially translates into a decision tree. So the rendering that you see here is from the GUI tool that you drag from that gets translated into a XML as it happens to be underneath into a set of language constructs, essentially decision tree, an event trigger decision tree. But that means that, for example, you can't have things like loops. You can only have a limited variable usage, and you certainly don't want to make it Turing complete. It's very much a domain-specific language, but you can write it safely without worrying about people sneaking in things under the hood. It's type-safe in the sense that you can't create any new types. It's control-safe. There's no loops or recursion, so somebody can't send you a script and suddenly basically hang your system by an infinite loop of some sort. And there's trigger limitations as well. There's no direct memory access, so there's no direct way to do corruption. There's no way to execute any script commands or shell command type of things. And you can check the safety of that language externally because it doesn't have loops. It has a known termination condition, so you can prove what it does. It can essentially traverse all the execution paths. So this is an example of a simple LESS script, which does the first example service I mentioned. It has an address switch, which determines who's calling. It has a device extension, a namespace, which does device control by sending things to we control our stereo locally through a SIP to X10 interface, and does the turn off at that point, and then does accepts the call. And there are packages which go beyond that, so for handling a variety of other things. This is an online event model. This is the second service or third service that was on that slide. For when somebody's online, you have an event coming in, an event happening, and you have then you send a message if it's of a certain type, and then it sends an instant message from that. Here you use rich presence, where you have if a place type, which is one of the rich presence variables, is of a certain type, quiet in this particular case, then you switch your device automatically to go into vibrate mode, for example. Sorry to do that here, but we have actually built a interface to Google to that using the location information. It was fairly simple to do. So here you can then automatically map location of devices, of systems from an external interface. Or the other thing we did was a local search version where when a call comes in, it looks at the device as the user identifier and automatically brings up the person name. Here, this is my student did this. Brings up automatically all the documents that are on my local desktop related to that person. As I mentioned, we need to move beyond just simply devices that look like phones. We want to have things which are actually embedded. So one of the things which is somewhat unusual for a project, I knew nothing about this before the Federal Aviation Administration approached us. So we actually they wanted us to build a system for training air traffic controllers. They have simulated pilots, when people play pilots, and they have trainees which want to become air traffic controllers in a room in Oklahoma somewhere in a classroom facility. And they wanted a voice over IP-based system because they could easily reconfigure the system to do that. Now, they don't want anything which looks like Windows Messenger, say, or anything else. They want a system which looks like a radio system to them and has all the properties like a radio system does, in a sense. You can talk automatically to multiple people. When you switch off of one channel, you automatically drop it, etc. One of the open issues that we have now, this is more like beginning work that we're doing locally, is that we have essentially now replaced most all of the old H.323 and ISDN world for multimedia collaboration. The one piece we have not replaced is T120. I don't know if most of you know what that is, but if you use NetMeeting, if you do sharing of slides or desktop sharing, that's what you're using underneath, is a ancient protocol which is out of the ISDN era called T120, which allows you to do some rudimentary sharing. That's all we got right now, besides WebEx and things like that, which are proprietary. So none of those work particularly well. We have VNC, which is really for remote access, or the RDP and things like that, and other platforms, but that doesn't really work well for conferencing type applications either. We looked at this problem as a community in the early 90s. X-sharing was lots of papers on that topic. We've not really succeeded much beyond that. We are now trying to work on this problem again, basically integrating it into a media framework and combining the notions of remote access, like we do today for remote desktop access, say, and application sharing into one framework so that you can use the same facilities for both. That actually turns out to be somewhat useful. In many cases, for example, when you want to access desktops remotely, if you want to access a game remotely, you have the problem that audio and video is on the other side. Using desktop sharing when there's an audio application or video application running doesn't work very well. Performance sucks, and the control doesn't work very well. So we want to basically make that look the same as if you're doing conferencing. So what we've been doing is doing a version here where you would have a remote access, which is exactly like a streaming media application. So keyboard and mouse input are just events on a streaming media channel running over RTP as a transport mechanism, often over TCP, but it works over multicast as well. And just briefly, kind of as an advertisement work that we're doing, talk about one other problem that I mentioned early on, namely the issue of spam-related things. The problem is that we don't have a problem right now because the systems are closed, but once the system's open, will have a problem of unsolicited messages. Skype apparently already has that to some extent. I've heard rumors, not used it much myself, that if you have a female-sounding name on Skype, that you have problems with people randomly calling you. And so here, the existing mechanisms that we have for email don't work. Bayesian filters, as good as they're going to be, are not going to be useful because by the time you can apply a Bayesian filter to the content, the annoyance has already happened. It's just not. Content filtering is not going to be a viable option for interactive communication filtering. You have to do address filtering, essentially. So identity-based filtering. PKI isn't going to work. That's not realistic. We've never made it deployable. Fortunately, unlike in the email case, we actually have a system which is reasonably usable in terms of authentication. Namely, the basic model that we have in this space is one of a model of two proxies, so-called trapezoid, if you kind of draw a figure here, where you have an outbound proxy in the domain, which authenticates the local caller, kind of what email is kind of evolving to by hook and by crook. And on the recipient side, you have a distribution MTA equivalent, namely the inbound proxy, which distributes the data, and that's the only way to reach that destination, just by firewall rules and other things. The difference is that we don't have an email kind of now, slowly emerging through the DKIM stuff and so on, is a trust model between those two domains. In the CIF space, we have the advantage, because it isn't as deployed yet, that the likely model of that will be mutual TLS authentication on a domain basis. So that gives us now a somewhat transitive trust model, namely here the two entities do just PK-based domain-level authentication. If I trust the domain, I trust it to authenticate, because all of them do it in all likelihood anyway, the local user, and vice versa. So that gives me a much stronger trust assurance than I have, at least in classical email models. However, we have to be careful. We tend to think of identity as only something which is a kind of either you have identity, you have a certificate, or you don't. In the voice over IP space, certainly that's not useful. So we've divided the notion of identity management into a number of domains. Namely, admission-controlled domains is the strongest ones, where you can actually have strict identity guarantees. In particular, it makes it difficult to acquire new identities. Many of these systems don't work if users can just randomly pick up new pieces of identity information. It just spamming becomes essentially, blacklisting becomes essentially impossible, for example. But if you know and trust that that other domain has strong identity policies, in the sense that getting a new identity, I guess you're in the process here, everybody here, of getting a new email identity if I interpreted the posters out in the hallway correctly. But generally, it seems to be a difficult process. You can't just go and get a new identity at Microsoft.com. That's not always the case. If you have, in some cases, you have somewhat limited identity assurance. You might have bondage domains only, where if you have enough money, you can get a new domain, but you have to have lots of money to get, new identity. But you have to have lots of money to get lots of identities, simply because each requires posting a bond of some sort. That's a useful subdivision that you can then use for black and white listing, for example. Some are membership domains, where you have no personal verification, but you have some limitations of creating lots of identities. Say you need a credit card number. And finally, you have open domains, where essentially within almost no constraints, somebody can create as many identities as they want. They're all authenticated within that domain, so they're legal within that domain. You just can have lots of them, and that essentially makes blacklisting impossible for that domain. Blacklisting somebody from Yahoo, say, or Hotmail is not useful, because if the person finds out that they're blacklisted, well, just get another address and can continue to annoy you. And finally, we have rate-limited domain, which make it difficult to get lots of domain over time, lots of identities over time. So we need to know more about domains than simply that they have a TLS certificate. We need to know what their identity policies are to do useful privacy filtering. So the system we're building right now is a system of what's called a trust path system. we kind of took the BGP model of distributing paths, vectors, routing information now for trust. So the basic problem that you have is Alice calls Bob. Bob doesn't know Alice. And now Bob has to make the decision, is Alice, presumably the device should make that decision, is Alice a spammer? And I don't want to talk to this person. I'm talking here in the example only about people. You can substitute domains for that. So if you say, I don't care about Alice itself, is the domain that she's calling from, is that a trustworthy domain? Do I want to talk to that, or is that somebody who's going to sell me timeshare condos? Okay. I may know Alice indirectly. That's the only one I have. And what we use for that, and the idea is not terribly new, we're just trying to implement it in a slightly different way, is the notion that the trust path actually goes the opposite way. Namely, it's a reverse path. So for example, if Bob has sent email to David, it means in all likelihood, unless this was a virus walking through their Outlook address book, that this was actually somebody they trusted enough to send him email. And similarly, if David had previously sent an IM to Carol, probably means David trusts Carol to the extent that they communicate. If you make the assumption it's a weak assumption of transitive trust, namely that the likelihood that even within a few generations, a limited number of generations or indirections, that you're unlikely to know spammers. They tend to kind of all live in the swamps in Florida for some reason. Most of us don't know them either indirectly or directly, that you're less likely, if you actually know this person, that it actually happens to be somebody you don't want to talk to. That is a very limited authorization trust model. It is not applicable. I would not extend this trust to sending Alice money based on that trust model. Just because somebody is a friend of a friend doesn't mean that they're good with money, even though my friend might be. But it is practically seems less likely that there are at least a relatively small number of people who are likely to annoy me. Okay. One other topic I want to just talk about here briefly, simply because it illustrates the notions of systems that we have, is the problem of emergency calling. That has gotten a lot of press when I've been talking to people that I've never thought I've talked to. I've gotten calls from Congressional Quarterly because I've been working in this area in this. And so they suddenly Congress people are getting interested in this topic. As you may know, if you followed the voice of IP world a bit, is the FCC got panicked because bad things happened. Basically, 2 people died because they had, in different instances, because they had a voice over IP phone that looked like a phone, was connected through an ATA and a converter device. Depending on one case was a babysitter, some other case was some other scenario. And the person didn't realize, picked up a phone, there's some emergency going on, intruder in one case, and medical emergency, I think, in the other. And they picked up the phone, dialed 911, and the only thing they got was either nothing or a message saying, sorry, the service you purchased, we didn't tell you that, but by the way, 911 doesn't work on this service. Not a good thing to find out, particularly in an emergency. So clearly this is one of those things which gets people all excited, rightfully so, even though the number of people affected has been very, very small. And so the FCC came down with a mandate and said, if you sell voice over IP service, which is called an interconnected service, namely one which actually connects to the phone service, you have to provide 911 service by November sometime. I think 28th of November, you have to provide that service. And by the way, before that, you have to send everybody a letter saying that until that time, you're going to not get 911 service, and they send you a bright orange sticker you put on your phone and all that. There's a lot of silliness going on there, but there's a lot of highest level concern because of the user expectation that this is no longer just a toy device, but it's a real device that people use for life and death type of scenarios. That's something we're not used to. I'm certainly not used to that. I mean, I never was under the kind of saying that I have to kind of this disclaimer that you have on devices not to be used for life and death situations that you might find on devices. Suddenly, we design systems where normal users have the expectation that they work, and they work in a predictable way. The problem with the existing system, the way that works is no miracles are going to happen by end of November. The technology that the 911 system has is very old and decrepit, and so it's very difficult to interface with it. So what they're doing are kludges, which kind of work, but they only work in the sense that you have to actually manually enter information about your device, namely where you live, on a web page, or they get it off your credit card bill or whatever, but it's your home address, essentially, that works. It doesn't work for a variety of reasons. Obviously, if you are nomadic, if you take your laptop or your phone, which you can easily do if you take all these voice over IP phones, clearly you can plug them in anywhere. That's the attractiveness of them. It isn't going to work. So even after the November, when most people will have done, complied with that mandate, 911 will kind of work in most residential scenarios, but as soon as somebody moves, even when physically moves, say if somebody got displaced because of a hurricane, took their phone with them, plugged it into their friend's house, didn't think about changing their address, they're going to try to dispatch to New Orleans or something. Okay? The other thing that we discovered recently, very recently, is that the existing infrastructure that we have, which has nothing to do itself with voice over IP, but now kind of converges in some strange way, is extremely brittle. We tend to think of 911 kind of thing, which is always around. When even if the world is going to hell in a handbasket, you can call 911. Hopefully, somebody will go and send an ambulance or something. Clearly, we found out in multiple ways that that's an unrealistic assumption. Purely from a technology perspective, we found out that there is that the system is designed to be very robust. They all have power backup, they all have a redundancy, but they're not robust against large-scale system failure. So in Katrina, we had 38 PSAPs be completely wiped. They had, when they flooded, they were wiped off, the building was disappeared, whatever. And the backup, the way that the current system works, it's a single backup. There's a primary PSAP is the public safety answering point. That's the point where you reach somebody when you call 911, the person that says, 911, what's the emergency? And that person, that PSAP has a backup PSAP somewhere, usually in a neighboring town, that did not anticipate that whole stretches of landscape would be wiped clean, and so suddenly you had no 911 infrastructure anymore. Particular what happened was that an existing phone system is hardwired, essentially. You can't just redirect 911 calls. They just go to one place, and if one place is not there, it goes to one other wire. But it is a wire, essentially. It's hardwired into a switch, a backup, and a primary. Once the backup is gone, you're off the map. So we now have these two colliding forces. We have voice over IP on the consumer side, about 1 million customers right now for the largest providers, probably several million total. And we have the realization, finally, that the existing system that we have has its own set of problems. So what makes voice over IP for 911 or 112, which is the European version, hard? Well, in a plain old telephone system, the phone generally is attached to wall jack and doesn't move, and you know where that wall jack is. In the voice over IP environment, in a landline environment, when you have a PSTN emulation, it kind of is a single landline phone number, but the phone number could be anywhere in the US. You can actually pick up a Vonage, say, service and get a phone number in a New York phone number, say. And in true end-to-end voice over IP, it gets worse in the sense that you don't have phone numbers at all anymore. And the existing 911 system relies very strongly on phone numbers. That's what it uses as a database lookup key, essentially, for everything. And the existing phone system, you have a regional phone company, your ILEC, incumbent local exchange carrier. And the transition voice that we have today, you have carriers which are nationwide or even international. Think of Skype, think of other the SIP providers. My SIP provider, for example, resides in Germany. And they don't know anything about the US 911 system. In an end-to-end voice over IP system, you may not have a carrier at all. You don't need a voice over IP carrier itself. We don't have email carriers, generally speaking, except for consumer applications either. We have a voice provider and line provider, layer 2, layer 3, and layer 7, if you want to use that analogy. In the old system, are all the same company. That's no longer true in both cases of voice over IP. You have an ISP and you have if you're lucky, you have a voice service provider. In the existing world, the Canadian, US 911 system operate completely differently from the Japanese and the European system, and each European country has its own system completely different. They have different protocols, they have different structures, different numbers for one thing, but even internally, completely different. That's no longer a viable proposition when you have international devices that can roam in anywhere. And if you have location-wise, you have a line location equals the physical location, clearly that's no longer universally true either. So the fundamental problem that we need to deal with is how do we determine location information? We need to locate the right PSAP and to speed dispatch. So these are really two separate problems. In the existing telephone system, location isn't that important because the wiring is such that even if I don't know where you are, the wire will just get you to the right local police station. They have to ask you where you are, but at least you're likely going to end up in the Seattle area. In voice over IP area, you have no idea where you are. You might be through VPN, you might be actually in a different continent. The locality doesn't exist, and we don't have a wire database. So there have now been several proposals for delivering location information to end system at layer 2, at layer 3, and at layer 7. And I won't go through those, but I'll be happy to talk about those more separately. There's a lot of effort now actually getting location to end system. That's very useful for actually people who are interested in ubiquitous computing type applications will find these very helpful, but the primary motivator right now is clearly 911 service. So the architecture that's evolving right now is one of where you have, let's say, a DHCP delivered location. So DHCP gets enhanced by a location delivery mechanism. A database mechanism running a protocol of some sort with a proxy server that consults that database and the voice service provider, say traditionally, which then routes to the call taker at your local fire station or police, whatever. We are developing a protocol which is a generic location to URL mapping protocol, which actually allows you to do mappings for both civic, street address type information, as well as geo information to services in a robust way so that you can have a variety of trees and redundant and all of that. Initially meant for 911 type of services, but actually works generically for that. There's several proposals along those lines, so this is one of them that we made. Skip that. Okay. I think in the interest of time, I'll probably stop here because I've started a new topic now. And that, let me just get to at least the conclusion slide. So we are seeing a slow transition, obviously, from emulating PSTN as the primary driver in voice over IP to new services, largely presence-based, often embedded. So there's a lot of interest, clearly, in embedding voice over IP, for example, in games, happening to some extent in a fairly ad hoc manner. Seeing a shift of emphasis, protocols are now pretty stable. There isn't really any great ferment of designing new signaling protocols, for example. That's been pretty stable now, but to architectures and filling in the gaps of that. We're seeing different provider combinations which lead to interesting kind of architectural issues. We still haven't, after all these years and hundreds of papers, we still don't have an interoperable, really usable collaboration infrastructure beyond just proprietary systems. Moving, as I said, from protocols to systems to infrastructure replacement, namely real physical infrastructure with all the social expectations on privacy, on security, on economic issues, on safety, and law enforcement, which I didn't talk about here, issues which fundamentally drive architectures. Nobody cares about beauty of protocols. They need to work with communities that I've been working with. They don't care about protocols. They care about that they can do 911 calls or do legal intercept, for example, and how that actually works and whether it's elegant, whether it's whatever, nobody cares there. It purely becomes a systems issue at that point. And I didn't talk about the management part. Okay, and I'll be glad to take questions at this point. Anybody? Yes, please.
You talked about work that's going on in application sharing.
Yep.
What do you recommend for data transfer in a particular fashion? What work is going on there?
Just like a file transfer type thing?
File
Transfer.
Settings.
Yep. So the one thing, I mean, there are two mechanisms that people are proposing. One is something where you just do it by messaging. That doesn't work for large messages. And then there's something called MSRP, which is a protocol effort which is just almost finished in the simple working group in the IETF, which is meant for unbounded size streams of data, basically. And that's for file transfer and anything else. What it specifically doesn't do right now is kind of the file aspect of it. It's not an FTP replacement. It doesn't have file management at this point. It's strictly, it's a byte stream between two consenting adults, so to say. Okay.
So the way you describe less, it can't have loops. You can't have conditions like keep trying till something maybe happens, or keep trying for 5 times so there's no recursions. You can't have that kind of condition.
You would have to build that into, and you would have to essentially provide that within the language itself. So what you can do, however, is not loops as that sense. What you can do is, because it has timers, I didn't talk about that. So you can actually, when an event occurs, you can trigger a timer, and yes, you would have to enumerate it actually. So that probably works well for small innovations, but it doesn't work well for the try until type of thing. That doesn't work.
Was this a conscious decision to limit the complexity of the language, or was there some other issue there?
Yes. The complexity was actually probably the secondary decision. The primary decision was one of safety. The concern that we had is I want to be able to give you a less script, as I'm assuming you've never seen the language, you don't want to look at it, and you should be able to install that on your system and trust that it doesn't do anything evil, at least at the language level, in the sense that it suddenly hangs your phone type of deal. Or more likely, the accidental case. It's very easy to not get the terminating condition right. And that the thing then keeps dialing every 5 minutes, forever. And kind of a sorcerer's apprentice problem. And so that's why we currently made the decision that we could do most of the services by just repeated timers, and it would be harder to shoot yourself in the foot with a large caliber weapon. So that's you can argue about the appropriateness, but that's the justification.
But when do you think we can catch up in terms of reliability?
Well, yeah, that's a good question. The question really is, how are we going to end up doing reliability? Because we've now done 2 models of reliability. One is internet type of reliability. One is multi-homing, and one is try and make the system itself more reliable. And the largest reliability problem that I think right now is actually happening is not classical network failures. I mean, my network, actually, my DSL has been up pretty reliably. I don't know what's here like, and our network at Columbia has, there's occasional interruption, but it's not 5 nines, but reasonably close. What I've had most problems with is reliability because of strange configuration issues, suddenly things breaking in unpredictable ways. That's really been more of the, rather than just lines breaking, the routing type reliability on that. So I suspect that what will happen is that we'll initially have multimodal reliability in the sense that you'll end up having 2 paths of a sort. 2 IP providers, 2 link layer providers, and 2 application layer providers as well. And that's something which I found very useful. Is actually on my laptop I have both a SIP connection, so to say, or an account to my home service at Columbia, as well as a commercial service. And if one doesn't work, the other one hopefully does work. So
you have the data, say, Vonage. How many lines do they have?
How many lines?
How many lines? 9.
9s. Oh, I don't know. We have done. This was about 2 years ago. We did measurements on just simulated IP phone connections. We got about 99.5 reliability. Now, things have probably increased somewhat since then, but it's not dramatically better. And there was a study, a Keynote did this, one of these measuring companies, which if you have $10,000 spare, you can actually get the details. I didn't, so I don't only have the summary information, which basically just give you a ranking. But there they said it's significantly lower. They didn't attach 9s to it. The problem you get is you get both call failures and call interruptions. And that's really what we found is that the call rate actually is pretty good, but you get lots of calls which suddenly get interrupted in the middle of a call for some number of seconds. In a sense, it comes back, but you lose connectivity, you lose voice connectivity. That seems to be the biggest problem right now.
So before, I know there are a bunch of questions. We are at 3 o'clock, so if anybody wants to leave, leave, and people who want to stay and ask questions, if you want to.
I'll be more than happy to do that.
Why
Sure.
don't we do that? But
Okay.
officially, we got done today, but your hand was up for a while.
So with respect to REST, your end user scripting language, how much effort do you believe end users are actually going to go into the site?
Before you go, we are 8,000.
Thanks.